Now that we've studied linear functions, we can move on to another class of functions, which are the quadratic functions. This has the general form f of x equals ax squared plus bx plus c, where a, b, and c are constants. And this gives us a lot of useful information about these quadratic functions. Some properties that are important. We want to make a note that the domain, since there are no fractions or square roots in this general form of the quadratic function, we can say that the domain is all real numbers, negative infinity to positive infinity. Another property is that we know that the graph of the quadratic function, the parabola, will open up if a is greater than 0. It will open down if a is less than 0. And if a is equal to 0, then it wouldn't be a quadratic function. We don't care about that case. And then property number 3 is the vertex. And the vertex is the minimum if the parabola opens up. The vertex is the maximum if the parabola opens down. And the x value for the vertex can be found using the formula x equal negative b over 2a. And the y value can be found by plugging the x value back into the function. Okay. Now the examples that we're going to be looking at here in this video is to be able to graph these quadratic functions. Okay, so here's one example to where the quadratic function is given as f of x equals x squared minus 5x plus 6. And ultimately, we want to graph the function. We can do that by first finding the vertex and then finding the x and y intercepts. That gives us a few points to help us, to help guide us on what that graph will look like. And then finally, graph using those points. And knowing that the graph has this general parabola shape, right? This bowl shape, right? If a is greater than 0, if a is less than 0, it's going to have this bowl shape opening down, what we were saying earlier. All right, so with this example, let's first begin by finding the vertex. And it may be helpful for you to label what our a, b, and c is. Right, a is 1. If there's not a number in front of the x squared, we assume that to be 1. B is negative 5. C is 6. So using the formula x equal negative b over 2a, we can find the x value. So we have a negative 5. That will become a positive 5 over 2 times 1. So that is 5 halves. I'm going to leave that as an improper fraction. We could rewrite that as 2.5, sure. Be careful on converting your fractions to decimals, though, because there are some fractions that has repeating decimals, and you would have to round your answer. Try not to round your answer. Not so important here, but when we get to the finance chapter, that's going to be very important. If you're rounding your intermediate answers, then your final answer is going to be off. So use exact numbers, use fractions when possible. All right, so our x value for the vertex is 5 halves. Now we can find the y value of the vertex by plugging 5 halves back into the function. So that's 5 halves squared minus 5 times 5 halves plus 6. Now I'm not going to go through all the steps here. This is something that you can plug into the calculator. 5 halves squared minus 5 times 5 halves plus 6. Just enter all that into your calculator. It makes it much easier if you do have a graphing calculator such as a TI-83 or TI-84, because you can type all this in and you can see what you're typing in. So this should simplify to negative 1/4. Take some time, work that out on your calculator, make sure that your answer agrees with mine. So the vertex is 5 halves, comma negative 1/4. All right, so next, I'm going to start with the y-intercept instead of the x-intercept first, because the y-intercept is easy to find. You don't have to show any work here. The y-intercept is found by letting x equal 0. Okay, but if you let x equal 0, then this x squared term is going to be 0. 0 squared is 0. And negative 5x, that's also going to be 0 because negative 5 times 0 is 0. So all we have left is 0 plus 0 plus 6. This y-intercept can be found by the constant of that quadratic function. So no work to show. You can show work if you like, but it's not necessary. The y-intercept is the constant of the function. Now the x-intercept, we got to show some work here. The x-intercept, you're letting y equal 0. In this case, you're letting the function equal 0. And it's going to be necessary to solve for x. We have a few options. We can solve by factoring. We can solve using the quadratic formula. We can also solve using completing the square. If you can factor the function, then I'd recommend factoring. In this case, not too difficult to factor. We know trinomials will factor into two parentheses where the first terms must multiply to equal the x squared term. The last term must multiply, the last two terms must multiply to equal the constant. And the last terms must add to equal the middle term. All right, so in other words, we're looking for two numbers that multiply to equal 6 and add to equal negative 5. Two numbers that would satisfy that is negative 2 and negative 3. Negative 2 times negative 3 is a positive 6. Negative 2 plus negative 3 is negative 5. Once we've factored, we set each factor equal to 0 and solve for x. We have x equal 2, x equal 3. Now this does not give us the ordered pair 2, 3. These are two separate ordered pair. Remember, for the x-intercept, we let y equal 0. So x equal 2 corresponds to 2, 0. And x equal 3 corresponds to 3, 0. Or the y values are 0 in those 2 points. All right, now that we found the vertex, the x-intercept, y-intercept, we may want to take a quick note to see if the parabola opens up or down. In this case, A is a positive 1, so it will open up. So it will be in this general shape here. Now we can plot our points to help us determine exactly where the graph is. So let's graph the vertex 5 halves, comma negative 1/4. 5 halves we said is 2.5 between 2 and 3. And the y-intercept is a negative 1/4. Right? Negative 1/4 is between 0 and negative 1, closer to 0 than it is negative 1. And the y-intercept is 0, 6. That's going to lie on the y-axis. And the x-intercepts 2, 0 and 3, 0. That will lie on the x-axis. Okay. And now we're ready to make this shape here. Right? Knowing that the vertex is the smallest y value, it's the minimum. So starting at the vertex, I'm going to draw my smooth curve through the x-intercept and y-intercept. And then on the other side, I'm going to, again, go through the x-intercept and make it the same shape as what I have on the left side of that vertex. You should see that symmetry. There's symmetry about the vertex. All right, so that's a good graph of our function, x squared minus 5x plus 6. All right, now let's take a look at a second example to where we want to graph the quadratic function. So in this example, we have a new function, f of x equals negative 2x squared plus 6x minus 3. Again, you can label your A, B, and C if you'd like to at the very beginning. A is negative 2, B is 6, C is negative 3. And on the first observation, since A is negative, we know the parabola is going to open down, so it's going to have this shape here. So the vertex is going to be a maximum. So let's find that vertex first. And the vertex is x equal negative b over 2a That's -6 divided by -4, which will simplify to 3/2. And so the y value can be found by substituting 3/2 into the function. -2 times 3/2 squared plus 6 times 3/2 minus 3. Again, you want to verify that you get the same answer as me, right? Make sure that you understand how to type all that into the calculator to get the answer. That should result in 3/2. It's just a coincidence that the x and y value for the vertex is 3/2. Okay, what about the y-intercept? Y-intercept is the constant, right? We said no work shown here. That's 0, -3. Okay, what about the x-intercept? All right, so the x-intercept, we're setting the function equal to 0. So 0 equals -2x squared plus 6 minus 3. All right, so you may want to take some time and see if you can factor this quadratic equation here to solve for x. You can play around with this, some trial and error. There's different techniques that you may have learned from a previous algebra class, the splitting method, the trial and error method. But after we play around some, right, you would see that this cannot be factored. So the factoring method doesn't work. So we go to the other method, which is the quadratic equation, the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so we plug in the -2 into the a, 6 into the b, -3 into the c. This is -6 plus or minus the square root of 6 squared, which is 36, minus 4 times a times c. And that's all over 2 times a -2. Okay, so if I simplify, let's simplify first inside the square root. -4 times -2 times -3 is a -24. 36 minus 24 is 12. That's divided by a -4. All right, so now the square root of 12, simplify that. Don't get a decimal approximation. I want an exact number. All right, so simplifying the square root of 12. Okay, 12 is not a perfect square, but you can split this into factors. All right, you're looking to rewrite 12 as a factor of two numbers, where one of those numbers is a perfect square. We can write this as 4 times 3. Right? 12 is 4 times 3. And the square root of 4, right, 4 is a perfect square. So the square root of 4 is 2. Now 3 is not a perfect square, so I'm going to leave that 3 underneath the square root. So the square root of 12 can be reduced to 2 times the square root of 3. So -6 plus or minus 2 square roots of 3 divided by -4. I can take a 2 out of all my numbers. Before I simplify this, or before I cancel any common factors out, I have to do it in all 3 terms, right? I've got this one term here, -6. I've got another term, 2 square roots of 3. I've got another term in the denominator, -4. I have to be able to take a number out of all 3 of these terms. So I can take a 2 out of all 3 of those. Taking a 2 out of -6, that's -3. If I take a 2 out of the 2 square roots of 3, I'm left with 1 square root of 3. And then in the denominator, that'll reduce to a -2. Okay, so -3 plus or minus the square root of 3 over -2. I'm going to multiply through here by a -1. That will just make it look nicer. That's a +3, and plus or minus, it's still plus or minus. square root of 3 over a positive 2. So that's my x-intercepts, or the plus or minus tells me that I have 2 x-intercepts. Let me come back here and split that. So I've got 3 plus square root of 3 over 2, comma 0 for the x-intercept, right? And then my other ordered pair is 3 minus square root of 3 over 2, comma 0. All right, these are the exact numbers. We like exact numbers. For the purpose of graphing, you may want to get a decimal approximation to graph, though. Now, as a decimal approximation, 3 plus square roots of 3 is about 2.4. 3 minus square roots of 3 over 2 is about 0.6. Okay, so now we've got the vertex, we've got the x and y intercepts. Let's plot these and then draw out our parabola. So the vertex, 3 halves, comma 3 halves, that's 1.5, comma 1.5. So here's 1.5 and 1.5. And that's the vertex. That's going to be our maximum since the parabola is going to open down. The y-intercept is 0, comma negative 3. And the x-intercept is 0.6, comma 0. That's 0.6 between 0 and 1. You don't have to get it exact when you're sketching these out. And 2.4, that's somewhere between 2 and 3, about halfway. All right, so starting at the vertex, we're going to go through the x-intercept and the y-intercept. And then the same thing on the right side of this vertex, making a mirror image of what we've already drawn. Like a mirror image, where you can think of the like a mirror going through the vertex.